So hello everyone, welcome. We will wait a couple of minutes for more people to join us, and we will start soon. So wait a little bit, please. So it's time to start our session, I guess. Good evening, everyone. Glad to see you all today. Thank you for joining. Of course, people continue to join us, so I'll make some kind of small introduction before. My name is Igor Makarov, and I'm .NET Dev in Godel, based in Minsk. Although we don't have many people today, but it's still interesting to know where you're from. So I guess you can text it in the chat. It's interesting fact will be. And by the way, this meetup will be recorded. Just a small point. I guess lots of people will be from Minsk, maybe Poland, Mogilov, Belarus. Minsk, Minsk, Minsk. Everybody from Minsk. Lots. And nobody is from Ukraine. Okay. Okay. Some facts about our company. Godel is a UK company with headquarters in Manchester. We have about 20 years experience on the market, and we have more than 1,500 employees across its dev centers in Belarus, Ukraine, Lithuania, Bulgaria, and of course Poland. What else? I guess it's enough for hiring part. You can easily check our website, contact us, and etc., etc., etc. And let's cut to the chase and finally proceed to the topic and the speaker. Today's speaker is Artsiom Ladzik. He is division manager at .NET division Lloyd's. Some of you probably might know Artsiom as a cool beardy guy. And he has 10-year experience, and today he will share some real-life cases based on his experience. So what is the plan today? First of all, Artsiom will present his topic, named from serverless to monolith. So by the way, what is your experience in this sphere? Because as for me, I don't have lots of experience, and for me, it will be very interesting to listen this topic. And after our topic will be some kind of Q&A session. So I guess you should make some kind of notes during our topic to not to forget your notes, questions. As you can see, almost everybody is like me, but 25% of clear understanding, it's well, I guess. But hope this topic will be interesting for you too. So Artsiom, it's a great pleasure to have you here. Over to you, I guess. Good luck.
Yeah, thank you very much. So let me just quickly share my screen. Just 1 sec. So I hope you can see it well, and I hope you can hear me well. So today we're going to speak about the path from serverless to monolith. So a bit unstandard topic, I would say, because usually we expect something to see like a migration from monolith to serverless or from monolith to microservices. But today we are going to talk about completely opposite thing. So just a couple of words about me. So you already know my name, so Artsiom. My role currently technical advisor and division manager in Godel Technologies Europe. So a bit more than 10 years of experience in software development, and my major is actually .NET and everything which is kind of around .NET and around software architecture. So yeah, and part of Godel Technologies Europe since 2018. So the plan for today is to speak about the GPS tracking system. So this is the real kind of life example from my experience. So I'll just tell you a story how we migrated from serverless to monolith and what benefits we got from it. And somewhere in the middle, we will cover just 2 small topics. We will talk about the architects and NFRs just to make sure that we are, on the same page with these kind of topics. So let's start. So first of all, we will speak about the GPS tracking system. As I mentioned, so this is the real life example. So from my experience, so 5 years ago, approximately, I worked in another company. So, and this is the project that I worked with. So in current world, I guess, pretty standard application, pretty standard topic. I mean, this GPS tracking system. So there are lots of them currently. So what was the business area, the business domain? So we can imagine that we have the United States, right? Lots of vehicles there. We have cars, vans, trucks. So lots of vehicles, and we have lots of companies who has vehicles in their pool, right? And of course, they want to have any kind of application, to track the position, to see the history. And in our industries, there are a lot of applications like this. But to be honest, the key functionality for all of them pretty the same. So usually those applications allow us to track the current state, to see the position, the speed, the state, to see the history, to define some kind of alerts, if the speed limit was exceeded or ignition was on or off. So it also allows us to, to create some reminders for maintenance, and to be honest, the approximately 80% of functionality of those applications, it's something about reports. So, on the very, very high level, so the design of those applications also looks pretty the same. So there is a vehicle, there is a special device that should be installed into this vehicle, and then this device just starts to produce a lot of data, and this data can be sent actually somewhere. I mean, it could be cloud, it could be on-prem solution, and eventually there is an application. Also, it could be web-based, desktop-based, or even mobile application. So, and eventually there are some managers or whoever who just use this application to see some reports, to see the state, whatever. So, yeah. So this is the really high level of high-level design of those kind of applications. So if we try to expand this cloud thing in the middle, so this will be the architecture that I would like to show you on the next slides. So, and this is the first version of architecture for this application that I worked with in a previous company. So the architecture looked like this at first instance. So on this slide, so you can see the example of Lambda architecture. So please do not confuse with Lambda functions. It's completely, different thing. So Lambda architecture means that we have two ways of data processing, and we can see it on this slide. So first of all, we have a set of devices, right? And all devices just send the data to some listeners, right? And then we have two kind of ways of data processing. So first of all, we have real-time processing, and eventually the data is being put into some storage. And we also have the second way of data processing. We just store all the data in a raw format without any changes. And, we just store this data in some data lake. So this data can be used at some point later. So if we need to build some reports, or maybe we need to process this data again, for any kind of reasons. But this is the example of Lambda architecture. So from a technologies point of view, for listeners, so the cloud service has been used. So it was hosted in Microsoft Azure. So, and cloud service has been used for listeners. So basically, this is the a set of virtual machines with the load balancer on top of it. So, and we can easily apologize. So we can easily deploy it from, I don't know, Visual Studio, from our pipeline. So, and we just get this amount of virtual machines with the load balancer out of the box. So for data lake, the table storage has been used. So it's cheap, it's fast, so no problems at all. So we can store any kind of data in it. So for storage, the MS SQL has been used. So a couple of reasons for that. So first of all, we had the strictly defined models, kind of, driver, vehicle, device, and, and a really good relationship between those models. And as I mentioned before, so 80% of functionality of those applications usually, reports. So lots of reports by mileage, by vehicle, by state, whatever. So lots of reports. And you can ask a question, something like, okay, so, but where is the serverless actually? Where is the serverless architecture? So basically, this serverless architecture inside of this real-time processing. So, and I'll expand it in a minute. So, but before I do that, so let me show you another thing. So we've already kind of covered the Lambda architecture. So, and let me show you another pattern. So pretty, I guess all of you know about this pattern. So pipes and filters. So usually this pattern look like this. So we have a message and we need to process it somehow. So we just put this message into, let's say, the first queue. So, and then the first job just grab the message from the first queue, do some work and put into the second queue. So then there is a second job, which just grab the data from the second queue, do some job and put it into the third queue, and etc. So it's kind of a chain of queues, jobs, and etc. So, and each job just does some work. So this is on the high level, the pipes and filters pattern. So, and actually, as I mentioned, so if I just expand that real-time processing, so we will see something like that. So if you can't read it, I mean, can't read the text, so don't worry. I mean, that's not something that we need to focus on. So this is just to show you the high level design. So just to kind of to show you the whole structure of this real-time processing. So all blue blocks on this slide are event hubs. So this is not quite correct, but this is a kind of queue. So in Microsoft Azure, so all green blocks on this slide are stream analytic jobs. So this is the special service which can use as an input event hub and as an output also event hub. Just grab the data from one queue and put it into the second queue. So, and all red blocks on this slide actually are Azure functions. So, and this is the high level design of that thing. So we can see the data flow, we can see the relationship, so we can see the chain of those operations. So of course, for now, I mean, for today, so not a lot of them, not a lot of queues, not a lot of functions, because in current world, we have projects with hundreds functions, 100 queues, but for 5 years ago, so it was a huge application from a serverless point of view. So for now, let me just pause for a while. So, and let me just show you this pretty green field. So usually when we join some company or project or team, so we usually work with the existing technologies, existing processes, with the existing application. I mean, everything is already defined for us, right? But all of us, we like to work with the Greenfield projects, right? When we can create something from scratch, when we have nothing, at the very beginning, no processes, no technologies, no cloud, no documentation, nothing. And actually, if we start to build something from scratch, even in 2021, so we still should ask a question like which architecture to choose. Either we need to use Monolith or microservices or serverless. And if you are a product owner or some guy from business, if you are not familiar with these terms, you have no experience, so you usually ask those guys, right? Architects. So there are lots of them. So I'm pretty sure that you are familiar with kind of these titles. I mean, you know about the solution architects, you know about the software architects, data architects, etc. So we will not speak about all of them. So we will just cover this topic on the very, very high level, just to make sure that we are on the same page and we understand who architects are. So, and that's the topic that I would like to cover, in the future, I mean, during the presentation. So architects, who are they and what they do? So to explain this on a very, very high level, so let me just show you this slide. So what can we see? So on the first picture, we can see the wheel, right? And on the second picture, we also can see a wheel, right? But if we imagine how those wheels have been designed, so we can guess that there were completely different requirements, right? To build the first one and to build the second one, but both are wheels. So, and this kind of the explanation what architect does. So if you work as an architect, so you don't need to build the fastest system ever. You don't need to build the cheapest system ever or the scalable system ever. So also, you don't need to focus on, your personal preferences in technologies. Let's say you're a fan of Python. It doesn't mean that you need to write everything in Python. Or let's say you're a fan of, I don't know, serverless architecture. It doesn't mean that you have to use serverless everywhere. So you don't need to focus on your personal preferences. You don't need to focus on modern approaches and trends. I'm not saying that you don't need to consider them. I'm saying that you don't need to focus on it. If lots of guys, around you use serverless or use microservices and use it because it's modern, so it doesn't mean that you have to use it as well. So the main goal for architect to build exactly what is needed for business and for the end customers. And actually, you may ask a question like, how to build this, right? How to become a good architect, how to build exactly what is needed. So the short answer is just to wear glasses, because if you wear glasses, so you just look like architect. So that's the first option, but of course it's it's just a joke. So the second thing is you have to build your own knowledge base. You don't need to have the deep knowledge in all these areas. So, but you need to have the kind of wide knowledge in cloud, in databases, in processes, in design patterns, in different languages, etc. So in our company, so we have such role, we have different kind of architects. So, and we help people to grow and sometimes become architects. So, and I've just collected a list of links that I think will be useful and helpful, to become architect. You can just easily scan it, and you will see this, document with this set of links. So, but let's go back to the initial conversation. So, because I still didn't answer on the question like how to build exactly what is needed, right? How to understand how to do it actually. So, and the answer is, so this is not this silver bullet actually, but please focus on NFRs. And the next topic is, small topic of this presentation is just to cover NFRs. So usually we speak in IT, so we speak about requirements, right? All business analysts, product owners, architects, developers, all of us. So we say requirements, 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 right? But actually all requirements can be split into two groups. So functional and non-functional. So functional is the stuff that customers need. So let's say I want to push on some buttons, I need to upload pictures, whatever. So this is the functional requirements. The non-functional requirements, so actually NFRs stands for non-functional requirements. So they also can be split into two groups. And the first one is business quality attributes. So this is the guys like time to market, like cost, like return of investments. So, and the second group is system quality attributes. You also may know this as architectural attributes, and those guys are security, availability, scalability, maintainability, testability. So lots of words in this kind of area. So, and of course, on top of it, we also have GDPR, PCI DSS, and lots of other stuff. But for now, let's just focus on NFRs. So we will not cover any other stuff except NFRs. So at this stage, when we kind of aligned on architect role, when we aligned what's NFRs, and for now, I would suggest to go back to the really initial conversation when we spoken about the architecture of the application. And now let's try to migrate from kind of serverless to monolith and see what benefits we can get from it. So this is the point when team and I, when we joined the project, and there was just one task for us: please analyze the system and give some suggestions, provide some suggestions how the system can be improved from a different point of views. So what actually we did? First of all, on this slide, you can see the architecture, the first version of the architecture. So, and you can see top 4 NFRs that I would like to kind of consider. So let's consider this. So first of all, the security aspect. So from a security point of view, we are in a good position because there's only one entry point in our system. So listener, we can only send the data. There is no way to get the data from listener. So that's the first thing. The second thing is we know all devices. So each device has the special firmware, has the special ID, hash code, whatever. So it means that we can easily filter unknown devices from our listeners. So it means that only known devices can send the data. So it means that from a security point of view, we are in a really good position. So the second NFR is availability. So because for listener, we has been used cloud service. So cloud service under the hood, it is a set of virtual machines with the load balancer on top of it. So that's why from availability point of view, we're also in a good position. So from a scalability point of view, so also because of a set of virtual machines and load balancer, but of course, another thing we should consider. So devices are not kind of real people, if you know what I mean. So there is no chance to have, let's say, 10 devices today and 1 million devices tomorrow. So because we need, so all those devices should be programmed, installed into some vehicles, et cetera, et cetera. So there is no chance that we should scale significantly. So that's why we are also in a really good position from a scalability point of view. But also let's consider, and those three attributes are from a system quality attributes area, but let's consider as well one business quality attribute, which is the most important, is the cost of the system. And to be honest, at first iteration, so the cost of the system was 13K per month. So it's too expensive. I'm not sure. So have you worked with such systems before? But please, kind of just believe me. So for this sort of system, so it's too expensive. So 13K per month. And so the idea was just to optimize the system from a cost point of view. So there was a crazy idea actually. So what if we just completely get rid of this real-time processing? So what if we just put all this logic, inside of our listener? What if we completely remove this real-time processing? And the reason for that, because 80% approximately of all cost is concentrated in this real-time processing. So because using this serverless architecture, so which was designed that way that I've shown you. So we had lots of queues, lots of functions, and we generated lots of traffic. And in Microsoft Azure, so we have to pay for traffic. So that's why 80% approximately of the cost was concentrated exactly in this piece of architecture, in this real-time processing. So yeah, and there was an idea, what if we just get rid of it completely? And actually we did it. So we created a copy of real-time processing and just put this copy into listener. So that's the first thing. The second thing, we just created a copy of the storage. So, and at that point, we've just started to process all the data parallel. So, kind of normal way. And also in addition, kind of we started to process all the data with a copy of real-time processing and put this data into copy of the storage. And of course, we created some sort of comparison app just to compare the data between those storages. So, because if we build everything, properly, so it means that the data should be exactly the same. There shouldn't be any changes, any differences, so in the data. So, and when we realize that we have completely the same data, we've started our migration from kind of old Rail to new Rail. So Rail means kind of way of data processing. So to do that, so we also introduced and added Redis into this application, and we've just put all IDs of the devices that should be processed kind of in a new way. So, and each time when listener get the data from some particular device, it just checked like either we need to process the data using the old Rail, or new Rail, so the new data, new way of processing. So, and at some point we've just migrated kind of all devices to a new rail. So, and we were able to completely switch off the real-time processing, to completely remove all that queues, jobs, functions, all that stuff. So, and eventually, so we can see the following picture. Of course, this is not the best application ever. So we can just agree on that. So, but from a security point of view, availability point of view, scalability point of view, we have completely the same picture because nothing has been changed actually. But from a cost point of view, instead of 13K per month right now, so we have just 2.5K per month. So which is like 5 times less. So what are the conclusions? The first thing is, please be pragmatic. So, and to explain this, let's look to the second point. So do not just trust to the following stuff, like serverless much better than Monolith. I mean, if someone says like serverless much better than Monolith or microservices much better, whatever. So we just need to understand like why, from what point of view, like what much better means, you know, from a cost point of view, from a speed point of view, from a dependencies point of view. So we need to understand why, and is it applicable for our particular case or not. So the second thing is like someone may say something like Monolith is a legacy approach. I also disagree, because all of us, we use smartphones, right? And either iOS or Android. So, and actually all mobile apps, they are Monolith. So most of desktop applications, they are also Monolith. So that's why kind of the definition, the message that Monolith is a legacy approach and we don't like to work with legacy, well, it's a kind of, it's not quite correct, right? So, or someone may say like, I would like to use microservices because it's faster. Well, it's also a tricky question. So faster, like in what case, you know, faster in kind of delivery will be faster, you know, the application will be faster. I mean, what will be faster? So we also need to kind of understand this. And the main outcome, I would say, from that I would like to, for you to kind of bring from this conversation is, if you need to build something, you know, properly, so please consider and focus on NFRs. So of course, it's not a silver bullet, it's can solve all your problems, but please consider them when building something from scratch, or you're going to optimize existing solution. Just focus on NFRs, and that's it. Thank you very much for listening. Thank you.
Awesome. Thanks, Artsiom, for such interesting topic. I hope we have a bunch of questions. But before we're going to start the session, I'm going to remind you how we can do that. First of all, we can raise your hand and ask a question via voice. So we will add you to this conversation, and you can ask a question, question by question, of course. In case if you're, for example, deep introvert, you can write it down to the chat, and then we can read it too. In addition, could you please just fill in our feedback form, because it's very important for us. We want to improve our events, and it will be very helpful. So thanks a lot, and let's start Q&A session. Any voice question, guys? Okay, Ivan.
Hello, can you hear me?
Yep.
Yep.
Oh, Artsiom, thanks you. Thank you. And my question is just maybe to make sure that I understood your diagrams right. So this real-time processing, was it removed completely, or all this functionality that was split between different functions was moved into listener?
So yeah, I got your questions. Yes, thank you very much. So let me just share the slide again, and I will just give you a bit more maybe context. One sec. Yeah, this thing. Let me show, yeah, this one. So yes, actually, we've just kind of built exactly the same function. So at first, it was a set of queues, functions, and jobs, right? So we've just kind of built exactly the same functionality just using .NET and put all this code inside of Listener. So because Listener was built in .NET, we've just rebuilt the whole logic, the whole behavior. So from this real-time processing using .NET and put it inside of Listener. So after that, so we just had exactly the same functionality, exactly the same thing that initially all those functions did, all those jobs did. So we just had all of this in one place. And this place I meant by kind of, and when I said, when I say this place, so this is the real-time processing copy. So, and yes, and the real-time processing, the initial one, so the set of queues, functions, etc. So we completely removed them from cloud.
And this listener was also scalable. I mean,
Yes.
there was a possibility to run several instances of it.
Yes. So it was a cloud service. Yes, cloud service by default, it is a set of virtual machines and the load balancer on top of it. So when you just deploy it, so you can easily define the amount of instances that you need. Let's say you can just define 5, 10, or whatever. So not sure about the auto scale, but for this particular application, so because we use the the real devices, so we didn't need the auto scaling, because so we could easily manage it manually.
And the database, so all these listeners were working with one database, am I right?
So yes, so there was so it was, yes, MS SQL. So there was a cloud solution. So the replication was turned on, but yes, this is actually a single database. I mean, as an object. I mean.
Okay, thank you.
Thank you, Ivan. Any more voice questions? Okay, maybe let's check Q&A section. There are some questions here.
Yeah, I can do that. So yeah, let me just go one by one. So the first one is, I have a question. I will read it so that sure everyone can see it. So I have a question to Artsiom as architect. So after you have created a design project, do you take part in the project development with the dev team, or maybe you finish working on that project after application architecture has been created? So for this particular one, I was responsible for design and I was responsible for implementation too, but I worked not alone. So we worked with the team. So there were 3 people in the team and I was kind of lead / architect for this particular team. So if I didn't answer on your question, so please just say something in chat. So yeah, I'll mark it as answered. So the next one is, how do you find a balance between dev team and client? So when dev team wants to try the newest technologies while business is interested the profit from project. Really good question. So how to find the balance, between the team and client. So when say team wants one thing and client wants another thing. So the most frequent answer from architect, so it depends. So, and this is exactly the same thing. So it depends. Let me say the following. If we have existing environment, I mean, there is a team, there is an application, we have the existing set of technologies, tools, processes, etc. I would suggest just to create a process how we add new stuff. So it could be some sort of forum or whatever, and there should be kind of concilium of the architects, leads, whoever. So, and if some developer or engineer or whoever just want to introduce something, let's say we use only .NET, but someone wants to introduce Golang, for instance. So please just create a sort of document, explain the benefits, the drawbacks, all kind of pros and cons that we will get if we start use this, Golang instead of using .NET. And please go to this kind of forum, and explain why we need to use it, etc. So, and if you get kind of approve or something, so yeah, let's just start using it. I mean, my suggestion would be kind of to create a sort of process how we introduce new stuff. So the tricky thing could be, let's say, from a pure architectural point of view, we approved something. Let's say, yes, we see the benefits to use Golang instead of .NET, but then we need to have a budget for it, right? So this is the tricky thing. And let's say, let me say the following. So if you work as an architect, so let me say this, you can imagine the situation when you join some project and you see that 99% services in .NET, but just 1% of services in Golang, and you don't have documentation, you have no idea how to work with Golang, you have no experience, but for some reason, there is a service in Golang and there are some tasks, to do some changes in this service, but you have no idea how to work with it. So, and this is the situation when someone before you, maybe a year ago or wherever, so tried this. So there was no kind of process how we introduced the stuff. So someone just tried something and now we just cannot support it. So I'm just saying this, that usually architect work, so you have to think about the future, right? I mean, not kind of where the project will be in like 3 years, in 5 years, and how will we support it during all this period of time. So that's why you need to kind of have some authority and stuff like that, just to maybe reject some proposal, propositions, or something like that. So, but definitely there should be a process how you introduce the stuff, and then either approve it, so or not. So if you think that this is definitely something that we need to use or have to use, so then yes, you can just approve it and then speak to business about the budget, etc. So, and in this, I apologize for such a long, answer. So, and in this case, if we need to kind of get a budget for something, so in this case, you as an architect have to speak in kind of different language. So if you speak with developers, let's say about CI/CD, you can speak about tests, technologies, whatever. But if you try to sell it to product owners, to business guys, you have to operate with such things like time to market. We can release faster. We can, release some features faster and much quicker than our competitors. There should be different language how we explain the things to the kind of one group of people, the second group of people, etc. So yeah, sorry for such a long answer, but I hope I answered. So I can see one question from YouTube. Any concerns about development deployment side? I can assume this real-time processing is not really big. Not many teams working on it, and there are no availability problems because of bugs. So, so let me answer kind of step by step. So the first one, any concerns about development deployment side? So, okay, so the team which supported this application was not too big. You are absolutely correct. I mean, just maybe 5 people worked on that project initially. So Okay. So yeah, no many teams. Yes, I partially actually answered on the second part as well. So, and there's no availability problem because of bugs. So I can't remember that we had some bugs with this, because initially we created, when we created a copy of this real-time processing, so we compared all the data against kind of two databases. So that's how we realized that we have exactly the same functionality, exactly the same way of data processing. So, and from a kind of changes point of view, we don't need to change this functionality frequently, because there are lots of changes at the end side, I mean, in the application side, but not between the devices and database, if you know what I mean. So yeah, there were no problems actually. From another question, so from architecture perspective, what tools have you surprised? What tools have surprised you recently? Trendy, new tools? Good question. Well, in my experience, current experience, so I mostly work with AWS. So in terms of tools, so could you just clarify your question? So apologize. I mean, what do you mean by tools? I mean, tools for architects, like, to design something, kind of to build the diagrams or for something, or by tools you mean like what do you mean by tooling? Yeah, apologize. Could you please clarify the question? For now, I'll just mark it as answered. Kirill, the question from Kirill Alyokhin, 2 questions. What was your real message? Apologize, let me just read it. What was your real message? Was it an apology of Monolith, or was it just an appeal to be more creatures when choosing an approach? Good question. So I think, well, my opinion that initially the approach was chosen improperly. So I mean, at the very beginning, so we just had to analyze the amount of traffic, we had to analyze the amount of devices, the real goal, we had to calculate the cost. So, and that's why at the very end, I mean, so that's why I think at the very beginning it had to look like something monolithic rather than serverless. So you mentioned desktop and mobile apps as an example of Monolith, but it's not like the same. And those apps may have wide serverless SMB. Yes, you're absolutely right. So, so yeah, of course, if we consider some mobile app, so for for the smartphone, so this is the kind of the front end thing, if you know what I mean. So, but it should be the backend side somewhere, which is yes the serverless or microservices. So, but yes, but the app as itself. So this is the monolith. There is no way to kind of host the app kind of as a several services, if you know what I mean. I mean, purely on the smartphone. Anyway, is serverless more usable for the backend architecture? Why is there a huge movement from monolith to serverless nowadays? Different reasons, actually. So serverless is much I don't want to say better, but let me say this: if you want to create some startup, let's say, you don't have a lot of traffic, you don't have a lot of customers, you don't want to care about how to host the app. You don't want to care about the, maintenance, about the support, kind of how to upgrade the versions, and stuff like that. So if you host something on premises, right, you always need to care about the versions, care about the upgrades, to support the operating system, etc., etc. So, but if you have an idea and you need to create something, from scratch very quickly, just kind of yesterday there was an idea, but tomorrow you want to see something which is which works, so serverless is a good thing. I mean, you don't need to just care about this whole thing, how to host it, how to build it. So you can easily just to build an app. So, and also serverless might be useful when you don't have the clear picture of what you need. So let's say you have an idea like, oh, I need this function, so you can just add it into your application. But tomorrow you're like, oh, I need this as well, so, and you can create it as a separate function. So it's kind of when you're in a process, when you're defining stuff, when you're kind of work in the real agile, when yesterday there were one requirements, but tomorrow you have and other ideas, other requirements. So it also might be useful to use serverless instead of monolith. So the second, third, or whatever reason is when you have lots of teams and lots of domains. Let's say there could be huge application and you need a lot of guys, of course, to support this entire thing, right? And you can, if you can, using DDD or something like that, so the split the whole up to the different domains, so that there will be no intersection between those. So you can just create a lot of teams, and each team will support just one piece of the entire application. So in this case, serverless or microservices, of course, will be much, much better than monolith. So yeah, that's, I guess, three main reasons. So about, yeah, there was a clarification about that question about the tools. About previous question, diagrams are the option. Any recommendations? So for me, I use okay, so Draw.io, is it correct pronunciation? So also liquid chart. So also there are a couple of tools to draw the sequence diagrams. So like web sequence something, so apologize, I can't remember the exact name of this website, but I think the most powerful tool is the plant UML. So it's a really simple thing, but lots of applications like Confluence, like Jira, like, I don't know, SharePoint, whatever. So lots of applications have integration with Plant UML. So that's why you can easily, and using Plant UML, you can build whatever you want. I mean, there are lots of stuff you can build using Plant UML. So really good documentation. So yeah, really good documentation. So yeah, this is the, I guess, the most powerful thing that I ever used. Yeah, thank you for your question. But in terms of tools, apologize. So yeah, in terms of kind of tools, maybe. So usually I just use the web version of the designer. So yeah. Well,
one more question was get in the chat and meeting. Thanks. Have you compared performance of the approaches?
Okay, one sec. Have you compared performance? Yeah. So yes. So of course. So we need also kind of clarify what do we mean by performance. Is it kind of a time between like when the data was sent and being put into storage? like if we mean the performance, like this time range, so yes, of course, we comparing the performance, and it was a bit faster. So the time, was a bit lower. So also want to have to say that I mentioned that listeners are the set of virtual machines, right? So when we put real-time processing into listeners, so we had to add a few more virtual machines because, just to be able to, to process all the data. But from a cost point of view, it costs nothing, actually. So yeah, 2 questions from Kirill that I've already answered. Like for plenty, okay. So yeah, and that's the thank you from Kirill. Yeah, thanks.
So
sounds like.
Any other questions, guys? I guess nothing. Okay. It was a pleasure to meet you at the session. Thank you for your time. I hope you enjoyed it. And do not forget that this is not our last meetup. Be in touch with our social networks updates and fill the feedback forum, and have a good evening, and see you later. Thanks a lot.
Thank you.